Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Before we talk about this material, let me introduce myself. My name is Fifi Yaya Mahe. My ID number is 4101422097. My study program is Mathematical Education and my supervisor is Mrs. Detalia Nuriza Munahefi, SPD MPD. So here we will talk about injective, surjective, and bijective function with using Geogebra. Before we talk about using Geogebra for proving injective, surjective, and bijective function, we will talk about what if the definition of injective, surjective, and bijective. So the first part, definition of injective function. What is injective function? Injective function is let f a to be a function from the domain A to the codomain B. The function f is called injective or one-to-one if it maps distinct element of A to distinct element of B. In other words, for every element y in the codomain B, there exists at most one preimage in the domain A. Or we can write for all x1 is 2 element A x1 not equal x2 implies fx1 equals not equals fx2. So if this function injective function are one-to-one, we will get the graph like this. The point 1 and point 2 is not same. On other words, we can say that the point of injective function are unique. If not injective function, if the graph have the same point like this. So what if surjective function? Let fa to b is called surjective or onto if for every one in the codomain B there exists less one in X domain A. Or we can write like this. For all y element B, there exists X element A such that y equals fx. If this function is surjective function or onto, we get the graph like this. x1 and x2 is the same point in the same codomain B. If not surjective function, the graph like this. The point of y2, y2 is not same. The codomain B have no partner in A, so this is not surjective function. The next is bijective function. Bijective means if it's both injective and surjective, or let f(a) to be a function from the domain A to codomain B, the function f is called bijective, one-to-one and onto, if for every y in the codomain B, there is exactly one element x in the domain A. Bijective function, if this like this. Or we can write the definition of bijective function. For all y element B, there exists exactly x element A, such that y equals fx. So the next This is we have a problems. Let f r to r be function. So the function of f is equal x power 3 minus y is an injective function or not. Prove it. So before we prove it by definition, we talk about before we will prove it using the Geogebra. Yes, this is here we prove will using a Geogebra. We will see what is the graph making for the function fx equal x power 3 minus 1. So we open the Geogebra. We write problems. The problem is fx equals x power 3 minus 1. So we will see the graph making for this function. So the graph for x power 3 minus 1 is like this. We can see that graph not have the point is the same. Didn't have the same point of the graph. So this is injective or one-to-one. Exactly the point is unique. And then we will prove with by definition by definition of injective function, take any x1, x2 element R where x1 not equals x2. So we choose x1 equals negative 1 and x2 equals 1. So we substitute x1 and x2 to the fx. So we get fx1 equals minus negative 2 and fx2 equals 0. So we have if x1 not equal fx2. So that therefore so we can conclude fx equals x power 3 minus 1 is an injective function. So this is we have the another problem. Let f r to r be a function fx equals negative 2x plus 5 is a bijective or not. Prove it. Yeah, this is again using Geogebra. We will see the graph for negative 2x minus plus 5. So we get the graph like this. This is a bijective function. Yeah. Why? Because what is a bijective function is stratifies for the uh, injective function and surjective function. So we will investigate is the injective or not. So take any x1 and x2 element R where x1 not equal x2. So we choose x1 equals negative 1 and x2 equals 1. So we get fx1
equals 7 and fx2 equals 3. So we have fx1 not equals fx2. So this function is injective. Let's see for the surjective. Surjective, we prove let y element r so that fx equals y, fx equals y, so substitute negative 2x plus 5 equals y. So plus 5, we will move to the right side. So we get negative 2x equals y minus 5, and then negative 2 we move to right side too. So we get x equals negative y minus 5 over 2. There's x, we substitute to fx, so we get f negative y minus 5 divided 2 equals negative 2 minus negative y minus 5 divide 2 plus 5. So since negative 2 and divide negative 2 we can eliminate. So y minus 5 we get y minus 5 plus 5. So we get y. So fx equals y. So this is proof it. So is it a surjective function? Since the function is stratified for injective and surjective, so we can conclude that is fx equals negative 2x plus 5 is a bijective function. So this is enough for me. Thank you for your attention. If any mistake, I'm apologize. And if you have a question or opinion about my material or my explanation, you can write in the commenter column. And see you next time. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.